Hey everyone, here for another episode of The New Stack Makers. And today our topic is a subject that I'm really interested in because it deals a lot with how we think about the infrastructure and how we think about setting up the infrastructure and how we think about that for Kubernetes and how we think about really using really big hardware and thinking that through with two of my guests, Chip Zoller, Senior Principal Engineer for Kubernetes on VXRail at Dell Technologies, and Bosky Salva, Technical Product Line Marketing Manager for Modern Apps at VMware. Chip, Bosky, thank you for joining us.
Thank you for having us.
Yeah.
I was just saying before our call that, I've covered enterprise for many years. And, one of the things that I really learned when I got into it, I would go to these mega conferences put on by IBM and Dell and VMware, and heard a lot about hardware. And I knew it was always essential for IT. And I was always interested in scale as well and what the developers were doing. And this space has really changed a lot. And so I'm curious about really exploring VXRail and how it plays into the story here. And I'd like to start off with that. And we're going to talk about some other things about how these complex challenges are emerging from proof of concept to production Kubernetes, how you can think of day two operations and management. We have a lot to go through, but I'd really like to just get started with this discussion about how does VXRail manage Kubernetes to make it possible to run cloud-native technologies. Maybe you could talk about the infrastructure of VXRail and how Kubernetes works on top of it. Chip, why don't we start with you, and then we can go to Bosky.
Sure. Well, VXRail is a nice package when it comes to that infrastructure because a lot of the complexity that's inherent in running enterprise infrastructure, a lot of that's removed. And that's not only from the day one setup process in which it's an easy wizard or even encapsulated in infrastructure as code, but going forward in day two, it makes updates and upgrades a trivial task in most cases. And so Kubernetes, when layered on top of that, can then take advantage of a lot of those capabilities through the VMware SDDC when it comes to things like storage and networking, and also the way that Kubernetes is able to manage their own applications in a desired state manner. It complements the VXRail infrastructure fairly nicely.
And so perhaps you could tell us a little about the infrastructure and how you've set up the infrastructure to be able to just layer Kubernetes on top.
Well, it ultimately comes down to the design and how to best do that, because there are multiple ways to go about doing it. But at the end of the day, when Kubernetes is laid down on VXRail, it's done in the context of VMware vSphere. And so based on the various topologies that you can choose for VXRail, Kubernetes is able to adapt to that in a lot of different ways. So it comes down to customer use case and simply how they want to deploy their VXRail, and knowing that Kubernetes, when deployed on top of that, can just work with it.
In many environments, the infrastructure can be quite tricky, Bosky, can it? And it comes down to, how the fluidity. And then there's also how everything is deployed and configured.
Yeah.
What's that process like for, on VXRail, and what makes it elegant from your point of view?
Yeah, definitely, Alex. So I think one of the things that, if you look at from a top-down approach, the end goal for, a stack like Kubernetes is really to give developers that magical experience where they can really, define their application needs and point them to an API, and then Kubernetes does the work for them. And most of the times, developers don't even understand where, the underlying infrastructure is, how they manage it, how, they're completely transparent to that process. And what Kubernetes does is really, it talks to the backend infrastructure and then, automates a lot of these tasks that the developer defines to make that magic happen. And so the infrastructure at that point in time, whether, it has to be fluid, it has to be compatible, or Kubernetes itself needs to understand how do I work with a specific infrastructure to make a lot of these things possible. And if you look at the open source project itself, Kubernetes has a ton of plugin architecture. So for example, it has plugin definitions for how it works on a compute or on storage or on a container runtime like Docker or something else. And a lot of these plugins, vendors come in together and they define how their products, how their infrastructure endpoints, can talk to, or Kubernetes can talk to them. So you look at, like, for example, if you take a look at the storage Kubernetes plugin, you'll see Amazon coming in talking to, or working on that upstream project on, making Kubernetes work with, EBS or something like that. Similarly, from a VMware's perspective, we are working within the open source community to make sure that, if a data store that's up in VXRail or presented through VXRail, Kubernetes actually understands how to work with that storage so that when a developer says, I need a persistent volume for my application, can you make it work? Kubernetes knows or understands how to work with the backend vSphere data store to make that happen. And so this VXRail package completely, the stack that we have created is essentially a combination of infrastructure like vSphere that, is good at, elasticity and scaling. At the same time, we are, bringing in components from the open source world like Kubernetes and the essential, backend plugins needed to make it work together, so that the overall experience at the end of the day is that solid, magical, thing that developers are looking for.
Can the developer and the engineer add their own components on top? I expect that they can.
Well, it really depends upon what components you're talking about. So for example, I'm a developer and I feel like I already have a stack and I want to work with a specific container registry that I care about more than what's out of the box in the stack. And sure, I can go ahead, deploy something like Harbor, which is a container registry, to work with it.
Chip, would you add anything to that?
I would just say there's a number of projects that are out there in the ecosystem, and so in many cases, there is a prescription of the batteries that may be included, but in many cases, if you don't happen to like that brand of battery, you can swap that out for something else. Maybe you're dealing with like an ingress controller, a way to get traffic into the cluster and then ultimately to the applications, which is really what matters from a traffic perspective, or authentication to some other system that you might have. These are components that there might be in some distributions and situations, they might be included, but there are things that you can swap out and also augment by adding additional capabilities that may not be prescribed at all.
Let's talk a little bit about starting with day zero, like, when an organization has decided that they're going to adopt Kubernetes, and maybe you could touch on that adoption path of what you're seeing and what what level of experience they have when we're talking about this. But I'd like to take us from day zero and thinking about the infrastructure itself, how they're thinking, the thinking through the storage, the compute, the networking, the data protection, and really that, mapping of workloads and containers.
Sure, I can go there. So I think from a day zero perspective, like, when we talk to customers, really, initially, a lot of times when customers are working or thinking about moving to a cloud native architecture, they tend to look at Kubernetes, the open source upstream project, and then, they try implementing it themselves. And oftentimes what begins as a simple project turns very complicated because now suddenly, just the upstream project is not going to help me manage. For example, how do I ensure that a developer accessing the Kubernetes API is authorized to do so? And so a lot of times you'll have to implement identity and access management. And a lot of times Kubernetes clusters are, you don't just see an enterprise running with a single cluster. There'll always be more than one cluster because, different teams have different needs and they need different, isolated structures to go about them. Identity being one example, each cluster has its own, RBAC or control policy. So you have to come in, and define what those rules and policies are. Security is another great example, like how do you ensure that, once you have the stack stood up itself, because the ability of Kubernetes to, let the developers really do anything they want. They can open up a port, they can create a service, etc. How do we ensure that what is getting deployed in that particular stack is safe, secure? So these are the things that I feel like a lot of times when customers start thinking about cloud native architectures, they tend to think about this as an afterthought and they go all in on Kubernetes, but then they realize, okay, we need to take care of all this. How do I even scale a cluster, right? I've seen times where customers start with a bare metal or, bare bones infrastructure, and then how do I add more compute power, more storage power and things like that. So, and then there are customers that really understand a lot of these components, or they're a little bit, based on their industry, they're a little bit cautious about going all in, and they think through a lot of these things. And I think the biggest challenge everybody still has is either, whether you're coming in from either direction, is figuring out what those components are, what your security posture looks like, how are you really going to manage your Kubernetes architecture at scale, how are you going to really manage your developers, how is your API going to be limited or rate limited, etc. And I think thinking about a solution that is elastic, that can, create a lot of these or take into account a lot of these day zero operations is key.
And so, Chip, when you think about that, you have a lot of experience in, working with Docker. You were saying to me beforehand that you were there in the earliest days. And when you were first using Docker and using container technologies and Kubernetes, what were some of those early lessons that you learned that you feel are smart to think about when you're in that day zero context, when you are facing these issues that Bosky has just surfaced?
Yeah, well, I think one of the biggest things to keep in mind is obviously the technical aspect is a big playing field, but it's a lot of the times it's really the human aspect when you're talking about day zero or the design phase, and getting an assessment of how much you know as an organization about this technology. Are you brand new to Kubernetes and cloud native apps, or have you been doing it in some form or fashion for a while? And what this automatically comes down to is the buy versus build argument. And we have a bunch of engineers that are chomping at the bit to go and build this platform from scratch. And, we're going to go off the shelf and pick all of these components, but that may not be the best approach for everybody. And what I see happening, and it was unavoidable in the early days because that's the only option that you had. But now that's not so. And you can choose from a lot of these solutions, including turnkey solutions that give you Kubernetes clusters as a service with all of the bits pre-wired in there. So you really have to take a step back and really assess yourself as an organization and ask, how much do we really know about this, and how far are we willing to go in order to fill that gap? Because there are products that fit each type of customer, but not every product or not every permutation of products is going to be right for every stage in the maturity.
So how do you approach it? So analyst who is Kubernetes certified is John Akiram, MSV, and he did an interview with me at KubeCon San Diego, and he talked a lot about the three parties, so to speak, in that Kubernetes environment. You have the developers who are essentially still trying to find the best platforms that they can use to build their applications. It's still relatively new. Cloud operating systems, for that matter, are relatively new. The cloud is still relatively new to a lot of people. And in Kubernetes, though, it's essentially running on, it's running on a network, and so you need that platform, so to speak. But that's emerging now. Now, then you also have what he calls the configurators, the people doing the configurations. And then you have the people doing doing the policy, for instance, and the governance. And there's almost like this mismatch, and there's like these multiple personas that permeate the entire type of, flow, so to speak, for that continuous delivery, if that's what you're seeking, whatever it might be. So what are the varying approaches that you're seeing in your customers and how they're approaching this complex problem? Because there can be a lot of overlap, even within particular areas such as storage.
Yeah, one of the very popular and successful approaches I see is, number one, acknowledging that this is a new technology. It requires a change of mindset, and that's really a human problem, but addressing it from the aspect of not having silos anymore, not having a developer silo, not having an operations team silo, where you have those problems that crop up. And now we have this disconnect between these two groups. Developers are speaking, developer terms, and they want to just be concerned with writing code and adding a business logic that delivers value. And operations teams want things to run smoothly. They don't want to get paged at night. They don't want to have to deal with upgrade nightmares. So this really speaks towards the DevOps movement, which is just a philosophy and operational strategy or model. But from a tangible human aspect, one of the best things that's come out of that is the concept of the site reliability engineer, in which case you have a persona that is able to straddle both of those relationships and be the go-between. They understand operations concepts, they understand development mentalities, and it's not a silo, it's a bridge between the two organizations. And in some cases it is the organization sort of organically grows around that. And so it's a mindset challenge, and it's an operational challenge, and developing a new persona based around that really is just focused on cooperation is what I ultimately see as being the most successful to operationalize this in production.
So that's an interesting discussion angle that we can follow here. Bosky, the role of the different roles people have and the emergence of the SRE. So once we get beyond day zero into day one, how do you start to see these teams evolve, and what are the trade-offs that they're needing to make at this point? When does this SRE become part of that picture?
Yeah, I think seeing like customers come at it from a very different directions and angles depending upon like team size, and sometimes you have organizations where typically the VI admin or the infrastructure admin, when they're moving to a cloud native role or a cloud native architecture, tends to adapt extended responsibilities and roles. So they'll start becoming the kind of not necessarily an SRE, but the platform architect that now also manages, the Kubernetes layer apart from the infrastructure itself. And then what I'm seeing is a lot of the DevOps teams or even development teams that are working or that are essentially, sometimes demanding a Kubernetes API, there'll be a couple of engineers within those teams that understand how Kubernetes backend works, how scale works, what are services, what are pods, what are replica sets, and some of the constructs that help them define application scalability, availability, and things like that. will be, working with the development teams in building these different configurations. So the dev team typically would write the code and things like that. And then the ops or the SRE or whatever you call them is essentially looking at it and going and thinking, okay, this is the scale requirement for that app. And here is my manifest for that application, my configuration for that application. And from a day, I think they really come into effect at day one. I think day zero is mostly where the platform or the infrastructure engineer is trying to build that particular stack up and running, making sure it's up and running. And what I've seen is sometimes there might be certain policies that, before they hand off that stack to the dev team, the platform operators might define certain baseline policies. For example, they don't want you to run any privileged mode containers. That is one policy that is pretty common that you see people deploying just to make sure that nothing unnecessarily should be running, nothing should have root privileges and things like that. So there are some baseline policies that we do see platform teams apply. And then once they're done, they then hand over that API or they enable the identity and access management such that dev teams can take over from there. They have full control of the API, and then they can start deploying their apps and things from there.
So Chip, when they're going through that, they've already chosen where to run Kubernetes by this point, haven't they? They've decided whether they're going to run it on VXRail, or they may run it on AWS, or they may run it on both, correct?
That's right, yeah. Those are some of the decisions that happen early on that are driven by things like cost, flexibility, but also governance, based on our compliance policies and the industry in which we're in. Where can we run it?
Right. And so when they're deciding, so they've decided where to run it. And so when they're at that point, what are they thinking about in terms of resource allocation? What are some of the approaches that you see people taking when they're thinking about that underlying infrastructure and how they allocate their resources?
I think one of the things that sometimes gets overlooked in that is the idea of the scale idea, but it's scale based on the unpredictable demand for the platform. And so what I mean by that is they might predict scale needs on their day one based upon their existing application, which might be running in virtual machines, or it might be running on bare metal. And then they move things over and things are working great, but then they forget about the adoption, and that is other teams that learn about that, and they say, hey, I want to run my application on Kubernetes too. I want to have the benefits of those things. Can you run it as well? Well, we might not have predicted that. We might not have made the assumption that we needed to accommodate scale for not just one app, but now dozens. And then it grows from there. So it often comes down to, where can we run this based on, acquisition costs and lead times, and then how do we actually make that scale happen with whether it's things like horizontal pod autoscalers, or the underlying infrastructure has to accommodate that. And that's something that VXRail does quite nicely, with the ability to just simply scale out by adding additional nodes. And you don't have to blow away your data center. You don't have to even disrupt the existing operations.
Bhaskar, would you add anything to that about the resource allocation issue when you're thinking about that? I mean, VMware is built on a premise of virtualizing infrastructure and, finding ways to allocate those resources, and curious on the reflections that you have on the changing landscape and what it means, for those organizations that are thinking about resource allocation.
Yeah, and I think I completely agree with what Chip said. And just to add to that a little bit more is, like, if you think, when organizations start, or, when teams start to think, okay, I am going to run my stack on Kubernetes or my application on Kubernetes, and here is a potential capacity that I might require or scale I might require. And what I find teams doing is they'll look at that and they say, okay, maybe 70% of something of that, extended capacities where we started or scaled that, and that we started that. But the good thing about the way, this is where I feel like people who run bare metal infrastructures versus maybe a virtualized infrastructure is, if you see yourself moving beyond that threshold, it is really simple to add another node, add another stack, and just get that, scale out pretty simply without necessarily, doing anything to your, necessarily getting into maintenance mode. And a lot of this is possible not just because of virtualization, but the way Kubernetes itself operates. Right? Kubernetes has this notion of nodes, and it can auto scale to any node. It can, let you dynamically add a new node to a cluster and things like that. So I think that's what, combined with, the elastic layer that runs beneath it, is the way people or folks go about it.
Totally agree. And I'll just add, Bosky's 100% right on that. But look no further than, well, basically every cloud provider in the world. How do they run Kubernetes? It's almost always run on virtual machines. Yeah. Regardless of who the underlying vendor is, that ability to scale those workloads, virtual machines are just a collection of software. They're files. So if you need to create horizontal scale and you have those organic growth needs, and you have a maybe unpredictable scale, it's a trivial matter to simply provision new virtual machines. That's a lot more difficult challenge to solve when you're running on bare metal. And you can't just simply drop in a new server, or maybe you can, but now you have all of that wasted cost that's sitting out there. Maybe it's even running hot, which is even more wasted cost. So it's a much simpler problem to solve when you're doing this in virtual machines.
But there's overhead too with the virtual machines, isn't there?
There's overhead in virtual machines, but it's not exactly an apples to oranges comparison, because that overhead, number one, it's very slight. And generally when I hear the argument of the overhead of virtual machines based on bare metal, it's assuming that you're close to 100% utilization anyway on bare metal, which is rarely the case. And if you are, you're probably in a position where you need scale right now. But you can think about the overhead as being as a charge for the massive amount of benefits that you get with virtual machines that you don't get with bare metal. One of those being a higher security isolation. So yes, you're paying a little bit more for it, but you're getting so much more in return that again, look at all of the major players that provide Kubernetes. Maybe there are a couple out there that are bare metal, but for the most part, Amazon, Azure, Google, etc., they're all under the covers. They're all virtual machines. True.
But I would like to ask, perhaps I can ask this question of Bosky, when you think about then in terms of, the historical context in terms of being able to, run your own virtual machine, and it would require some IT management to support that. So the actual setting up of the virtual machine and the actual running of the virtual machine. And it could take some time to do. And developers, are looking for continuous delivery. How has the virtualization, adapted to that? And a lot of it comes down to, I think, in how you think about your overall clusters and how you manage those clusters and how you architect your infrastructure.
Yeah, definitely. So I think we have come a long way from that, in the sense that, and I'll give you a specific example. 5 years ago, if you wanted a virtual machine that, you'll have to define to IT what size of virtual machine you need, how many CPUs, virtual CPUs that should have, what is the storage on that virtual machine, etc. Everything was bound to that virtual machine. But if you look today, I think we have identified that, binding everything to a VM is what is restricting, in the sense, it was a pretty restrictive architecture to look at when it came to scaling, because sometimes I just need more CPU power than storage power. And sometimes I need to, scale my application in a way that, I just need more inherent CPU power. But if you look at the way we went about doing that, we would replicate a VM over and over again. with the same amount of storage, with the same amount of memory, etc. And what it came down to really is, and one of the reasons why I think even cloud providers, why developers are so attracted to these technologies, is that they have the ability to define application requirements completely separate from, defining just a virtual machine. Today you can say, okay, I need CPUs, I have an elastic instance that I need, or I need a particular storage that is, so-and-so gigabytes or terabytes. And the ability to combine the two together really gives you that advantage. And I think that is where at least vSphere has come together. Today, today you can define, for example, volumes as a first-class citizen in vSphere and VMware, whereas 5 years ago, that was not a possibility. So if I had an application, I had to really construct that around that VM. And today, I can define my application in a very simplistic VM that could be just 2 GB long, but I can define my storage needs separate of that virtual machine and attach it to it, right? So I think virtualization in that sense has progressed, wherein not everything is tied to a VM. We are differentiating between compute, storage, etc. And then when you layer on Kubernetes on top of that, that just makes it so much more powerful, because now, Kubernetes can individually talk to these different components and can architect together, container runtime along with the virtual machine runtimes.
When you start to think about, all of this, and you're thinking through then that cluster management, you have to take into consideration backup. And backup has historically been something that you did with another data center. And I think it's still very true to this day. But there's a lot of innovation happening in backup, isn't there, in terms of how you can replicate clusters and how you can think about security with those clusters and the scale. Can either of you speak to that?
Yeah, sure. I can start with that. I mean, one of the things that makes Kubernetes attractive is its super awesome ability to run stateless apps. And with a stateless application, in which case that there is no data that's really being stored that represents that app, then it's a trivial matter to run that app. You can run it over and over and over again, multiple places, and you don't have to worry about things like backup. So backup is and there's multiple aspects when it comes to backup and data protection. And that could be of the infrastructure itself, that could be of the configuration that represents the cluster, and that could also be the applications that run on top of Kubernetes. So I'm talking about stateless applications. That may be a case where you don't really need to have anything backed up. You might have, and you probably do, have multiple clusters running anyhow, with multiple replicas of that application running across them. And this gives you something like hot data centers that were previously really difficult to do with applications that weren't designed in a cloud native manner, because then you have the problem of you generally stateful services like databases, regardless of whether that's like a SQL or Exchange or something else. And how do you deal with data locking and quorum and witnesses? And so that was a much more difficult challenge to handle. But with Kubernetes and stateless applications, your backup can basically, you're deploying to Kubernetes as code anyhow. And so your application is codified to begin with. And if you're not having to worry about saving that state, then it's a simple matter of deploying that elsewhere and getting back up and running.
And just to add to that, there are folks that, that run stateful applications too on Kubernetes. And the thing is, back in the days when we had to back up an entire data center, mirror it to another data center, really, it was the reason why, if you think about why that was done, is because everything again was tied to a virtual machine. You had, the virtual machine files, and you had the storage all together in a single, storage subsystem. But as we are moving towards Kubernetes and these cloud native architectures, a lot of that, the front end of the application, or sometimes, even the back, the back end servers that, applications need, are broken down into these microservices. And so you definitely, you'll see that a particular service may not be stateful, and only a particular component of the entire application may need persistent storage or persistent data. So backup suddenly now does not necessarily mean, backing up a VM, because honestly, there is no VM to back up, because an application is into a container and it is divided up even within multiple containers. But at the same time, you have all these configuration elements that are essentially sometimes stored in a CI/CD pipeline, where the runtime configurations of that applications or how the application behaves might be stored in that CI/CD pipeline. And then when the application runs, the persistent storage is pretty much the basic thing you would want to back up. And there are like multiple tools that you can use just to back up individual storage elements. And if in case of a disaster, all you have to do is point your CI/CD pipeline back to the Kubernetes API and reattach from a backup for that persistent disk. So backup is changing a lot, I think, with cloud native architectures, and the way we are thinking about backup is completely redefined in today's world.
I think in this last part of our discussion, I'd like to talk about, the commitment to open source that Dell and VMware are making now, and how it relates to VXRail. And as I understand, you have Dell and VMware able to curate open source components, and then the teams can then integrate these open source components. Can you tell us about that process that you've developed, and how open source components are layered on top? Kubernetes is open source, right? So I'd like to just get some daylight into that discussion, into that topic.
Yeah, I think I can start there, Chip. So when it comes to open source, there are multiple ways to think about it, right? One is definitely contributing to those projects that we are leveraging in some of our products. So you'll see a lot of VMware Dell folks, in the open source community out there contributing to the projects. And so that is one aspect to being behind open source. And then second is, coming up with our own projects. And, so for example, when we were talking about backup, like we have, an open source project called Valero, which is essentially a backing up, volume drives from containers to any given cloud provider or on-prem data center. And the idea is that, we really want to create an ecosystem around Kubernetes that leverages or that provides tools and capabilities that, makes life easier for enterprises, makes life easier for users. So that is the second set of things that we are doing. And then thirdly, the way we are integrating these components back into the products that we bring to the table is essentially, for example, if you look at some of the products that VMware has, we take our open source Kubernetes bits. We don't try to, the idea is to stay upstream as close as possible to the upstream. We don't really do anything to the bits, but essentially we repackage them, and then we will make them work with some other components. So for example, there's a network provider or a CNI provider that we feel is good for this particular product. We'll package it up such that when somebody deploys Kubernetes, they also have an out-of-box CNI provider to work with it. So that is, I think, the third element, or the way in which at least VMware and Dell are trying to create or curate projects that are based on open source technology.
Chip, you've worked in open source a long, long time. Back, as far as I know and what we've talked about, what is your thoughts on integrating open source components? They're just part of life. They're just part of the work. And so how do you think about that?
One of the nice things about what VMware is doing, and Bosky gave a good overview of what that is, not only contribution to the upstream open source projects, and that is contributing code, materially impacting the product at the end of the day, the open source project, but bundling those together in such a way so that they best represent or best enable the capabilities of their platform, but But Dell Technologies with VXRail is able to just seamlessly run those components. So if you wanted to bring your own proprietary system, maybe that you developed in-house, but you also wanted to use some open source components, great, bring them in and let's play together and talk to VXRail Manager and consume the APIs with any tool that you'd like to use. It doesn't necessarily have to be our own, but that flexibility is there, that openness to use any tool that you want to accomplish your specific job, and your set of tools are going to be different from somebody else's set of tools, but they just work, and they don't have to work with any specific caveats, or there no agreements or nothing like that. You simply bring what you want. If it's open source, select the open source tool that you want. It integrates with everything seamlessly.
I'd like to just finish up and moving into that day two discussion and where companies go. How you see companies using VXRail going into day two. Let's just assume that a customer has chosen VXRail. They have an installation method, correct? It's very much turnkey, as I understand. You can then decide what components you wish to use, and you can use you may have one cluster, you might have multiple clusters. Perhaps you could take us from there. These decisions have been made, but now what are they doing in day two? What are they enabling? What are they doing from a data security standpoint, from image availability standpoint? All these issues that come into play, such as upgrades and security and images.
Yeah, so their upgrade or day two operations is a convenient label that we've applied to lots of different type of operations, and those operations occur at multiple levels, not just the infrastructure level. But when we're talking about Kubernetes, there are lots of day two operations that are specific to Kubernetes in general to the underlying infrastructure. So when talking about VXRail specifically as a platform, the most common day two activity that has to happen from an underlying infrastructure are updates, or maybe that's upgrades in the case of a major version. And one of the challenging ones to stay on top of is security, because there are multiple components that you have to secure. And then you have to deal with this matrix of which needs to happen first, depending on what. VXRail bundles all of those things together so that you can upgrade or update your entire stack very easily, and know that you're not going to have to match those components you're not going to have to match them manually and go and research and find out on whose compatibility list these things are. It's all done for you. But the second option that's fairly common, especially when we talk about Kubernetes and cloud native environments, is horizontal scale. And Kubernetes enables that very easily with things like replica sets, in which additional pods can be brought up if not only reacting to pod failures, but also the need to on-demand scale things. VXRail complements that fairly well with the ability to add nodes so that your underlying infrastructure has that horizontal scale as well. And it's the same type of easy process where you don't have to re-architect things. If you need more compute capacity, add more compute capacity. If you need more storage capacity, and maybe you're doing stateful workloads inside of Kubernetes and you need to extend your vSAN environment, no problem. Scale up the existing nodes by adding more capacity. So those are two of the common approaches when it comes to day two operations.
So Bosky, could you illustrate this from a use case perspective as well when you address this for us? It'd be very helpful.
Yeah, sure. So I think I can think of at least 3 different use cases. One is, upgrades that Chip talked about. Kubernetes is rolling out another version of, every 3 months, they roll out a new version of Gates, and development teams will say, okay, I need that new API. There's something new and fancy in there, and I need that. So the underlying, VXRail platform gives you the ability to just click a button and say, upgrade that cluster or upgrade X number of clusters, right? So that is pretty neat. And then think about from a security perspective, like there are so many, no code is really completely secure. There'll always be bugs. And sometimes these vulnerabilities that we find are very much intense and we need to apply patches immediately, right? So I think that's another example of day two, when let's say, something was detected, either it could be in the subsystem, like, the virtual machine that holds a cluster together, the operating system that runs in that virtual machine had a security patch or a vulnerability that was detected. And you now need to go in and immediately fix that without really causing, complete shutdown of your platform. And so I think the way VXRail handles that is really cool. I think so. Those are some of the day two operations. And then, of course, the scalability, the addition of, scaling out capabilities that you get with compute, storage, etc. I think those three are the key use cases from a day two perspective.
So my last question really speaks to the future then, thinking about day two and beyond. What considerations should businesses have when they're thinking about the vendor solutions out there, and when they're thinking about, extending their infrastructure and finding more use cases for VXRail and for layering Kubernetes and open source components on top? Chip?
I think a lot of that comes down to selecting something that is easily integrated. And in our day and age, automation is king. Everything is automated. Everything has to be automated. And so finding that solution that not only integrates well with other things, but also gives you the ability to automate that thing and also extend that over to other solutions. Because when you have, especially when you in enterprises, when you reach large scale, or even before you reach large scale, if you have constant churn that's happening on top of things, point and click doesn't scale too well. No matter how many people that you have, not only to mention the human error factor. So finding a solution that has those automation capabilities, that's open, that's well documented, that you can use to integrate with other things easily and quickly, means that you can treat everything as code basically at that point. So that sense of openness and that automated ability is one of the big things.
Yeah, and just to add to that, I think you need something that is completely automated, like Chip mentioned. Your infrastructure should be fluid. It should be capable of scaling out, elastic, etc. And at the same time, whatever tools and solutions you select, it should have an out-of-box capability such that you get that really nice day one experience where you don't really have to think about, okay, I have this now, I have Kubernetes, but what about security, or what about something else, right? So you want to have a solution that caters to at least a baseline of requirements that your organization may have out of the box. And at the same time, giving flexibility in terms of what components can be pulled out or what components can be pulled in based upon, maybe some custom requirements. I think that would summarize what I would want to add to that.
Well, thank you both for your time today and talking about this interesting consideration when adopting production-ready Kubernetes and thinking of it in the context of VXRail, think of it in context of starting really from the very beginning and how you're thinking about it from day zero and going through day two and beyond. I want to thank Chip Zoller, Senior Principal Engineer, Kubernetes on VXRail at Dell Technologies, and Bosky Salva, Technical Product Line Marketing Manager for Modern Apps at VMware. Thank you both for taking the time to talk today.
Thank you, Alex.
Thank you.